In this video, we're going to complete the KutaSoftware Infinite Calculus free worksheet, Differentiation, Inverse Trigonometric Functions. Now, before we jump into this worksheet, I'm going to go over the 6 common inverse trigonometric functions and their derivatives. If you already know those, feel free to fast forward to where we jump into the problems. But at the moment, I'm going to quickly go over each of the derivatives. First, we have the derivative of the inverse sine of x, and that's equal to 1 over the square root of 1 minus x squared. And the derivative of the inverse cosine of x, that's equal to the opposite of 1 over the square root of 1 minus x squared. And these two derivatives are true for a domain of -1 is less than x, which is less than 1. Now the next two inverse trigonometric functions we're going to go over is the inverse tangent of x and the derivative of the inverse cotangent of x. And as you'll see, grouping the similar ones together, it's easier to remember the derivatives in our heads. Because for the derivative of inverse sine, we just take the opposite of that, and that's the derivative of the inverse cosine. And with the inverse tangent of x, that's 1 over 1 plus x squared. And for the inverse cotangent of x, that's the opposite of 1 over 1 plus x squared. And now these values are for all real numbers. Negative infinity is less than x, which is less than infinity. Now lastly, we'll have the derivative of the inverse secant of x and the derivative of the inverse cosecant of x. The derivative of the inverse secant of x is going to be 1 over the absolute value of x times the square root of x squared minus 1. And for the cosecant, it's going to be the opposite of that. So the opposite of 1 over the absolute value of x times the square root of x squared minus 1. And this is true for when the absolute value of x is greater than 1. So now that we know each of those, let's jump into our worksheet. We're going to be differentiating each function with respect to x for numbers 1 through 8. Looking at number 1, we have y equal to the inverse cosine of negative 5x cubed. So we know that we're going to be using the chain rule. So writing that chain rule out, y is going to be equal to the inverse cosine of u. And u is going to be that inside function of negative 5x cubed. So when we find the derivative of y with respect to u, remember the derivative of the inverse cosine is negative 1 over the square root of 1 minus the variable squared. So 1 minus u squared, since we're differentiating that with respect to u. And because we know what u is, we're going to plug u into dy du. So that's going to be negative 1 over the square root of 1 minus negative 5x cubed squared. And then the derivative of u with respect to x, that's going to be the derivative of negative 5x cubed, which 3 will get multiplied to negative 5 to be negative 15, and then x to the 3 minus 1, or x squared. So when we find the derivative of y with respect to x, we're multiplying dy du by du dx, calculating the derivative of the outside and multiplying that by the derivative of the inside. So that'll be negative 1 over the square root of 1 minus negative 5x cubed squared times negative 15x squared. Now how I'm going to simplify this is you'll see that negative 15x squared will get multiplied by negative 1. So we'll have 15x squared in our numerator. And in our denominator, I'm going to distribute this squared to both the 5 and the 3. So that 15x squared is all over the square root of 1 minus negative 5 squared is going to be a positive 25, so that's minus 25, and then x cubed squared, that's x to the 3 times 2, which is x to the 6th. So our derivative of y with respect to x in number 1 is 15x squared all over the square root of 1 minus 25x to the 6th. Now let's move on to number 2. In number 2, again, we're going to be utilizing that chain rule, taking the derivative of the outside and then the inside. So let's set y equal to the inverse sine of u. Then u, that inner function, will be negative 2x squared. So the derivative of y with respect to u, the derivative of the inverse sine of u, is going to be 1 over the square root of 1 minus u squared. But we know that u is negative 2x squared. So we're going to plug negative 2x squared in for u. So that's going to be 1 over the square root of 1 minus negative 2x squared squared. Now if we want to simplify this out now, as opposed to simplifying it later, we'll have 1 over the square root of 1 minus, now we're going to expand this term out because the exponent of 2 will be applied to negative 2 and x squared. So negative 2 squared is a positive 4, so we're subtracting 4 times x squared squared, which is x to the 4th. Now let's calculate the derivative of u with respect to x. So the derivative of u with respect to x is the derivative of negative 2x squared. 2 will get multiplied to negative 2, so that's negative 4, and then we're subtracting 1 from that exponent value. So we'll have negative 4 times x to the 1st, or negative 4x. So now when we multiply to get dy dx, that's dy du times du dx, which is 1 over the square root of 1 minus 4x to the 4th times negative 4x. So that's going to be equal to negative 4x all over the square root of 1 minus 4x to the 4th. So that's the solution for our derivative in number 2. Now, moving on to number 3, we have that y equals the inverse tangent of 2x to the 4th. So again, we're going to utilize that chain rule, setting y equal to the inverse tangent of u, and u is equal to that inside function 2x to the 4th. So the derivative of y with respect to u, that's going to be the derivative of the inverse tangent of u. The derivative of the inverse tangent is going to be 1 over 1 plus u squared. And remember, we already know what u is, so we can plug that back in. So we'll have 1 over 1 plus 2x to the 4th squared. Now I'm going to simplify my derivative of y with respect to u in this step. So I'll have 1 over 1 plus 2x to the 4th squared is going to be 2 squared times x to the 4th squared. 2 squared is 4, and x to the 4th squared is x to the 8th. Now I'm going to take the derivative of u with respect to x. The derivative of u with respect to x is the derivative of 2x to the 4th, which 4 will get multiplied by 2 to give me 8, and that'll be x to the 4 minus 1, or x to the 3rd. So when I found the derivative of that, if you remember, that's using the constant multiple rule and the power function combined. So my last step, I know that dy dx, the derivative of my entire function, equals the derivative of y with respect to u times the derivative of u with respect to x. So I'm going to be multiplying those together. So I'll have 1 over 1 plus 4 times x to the 8th multiplied by 8x cubed. So simplifying, 1 will get multiplied to 8x cubed, so I'll have 8x cubed all over 1 plus 4 times x to the 8th. That's my derivative in number 3. And if you want to write this in order of degree, you could have 4 times x to the 8th plus 1. Either way will give you the solution of the derivative. So let's continue on to number 4. In number 4, we're doing the same methods as we did in 1, 2, and 3, except this time we're using the inverse cosecant. So we're going to have y equal to the inverse cosecant of some function u. And that function u is that inner function of 4x squared. So taking the derivative of y with respect to u, the derivative of the inverse cosecant of u, that's going to be negative 1 over the absolute value of u times the square root of u squared minus 1. So simplifying this, that's going to be negative 1 over the absolute value of u is the absolute value of 4x squared times the square root of u squared minus 1, which is the square root of 4x squared minus 1. Now simplifying this further, I'll have negative 1 all over the absolute value of 4x squared times the square root of 4x squared. That'll be 4 squared, which is 16, times x squared, which is x to the 2 times 2, or x to the 4th, and we're subtracting 1 from that. And when we find the derivative of u with respect to x, that's going to be the derivative of 4x squared, which is 8x. So for the derivative of y with respect to x, we're multiplying the derivative of y with respect to u times the derivative of u with respect to x. So that's going to be negative 1 over the absolute value of 4x squared times the square root of 16x to the 4th minus 1 times 8x. Now we know that this 8x is getting multiplied to the negative 1 in the numerator. However, because that entire denominator is multiplied by 4x squared, we can simplify because 4x squared and 8x have a common term, and that is 4x. So if I divide 8x by 4x, I'll get a positive 2, and I'm multiplying that positive 2 by a negative. So this is going to be negative 2 all over 4x squared divided by 4x is going to be x times the square root of 16x to the 4th minus 1. And that's my solution in number 4. Negative 2 over x times the square root of 16x to the 4th minus 1. Let's continue on to number 5. In number 5, we're going to be utilizing the chain rule again, except this time we have some function to the third, then the inverse sine of some function, and then that innermost function. So the derivative of y with respect to x, talking through the chain rule, we're first going to do this outside function, essentially u cubed. So the derivative of that is 3 times u squared. But our u, in this case, is the inverse sine of 5x squared. So the inverse sine of 5x squared and then squared, because you can see we took the 3, multiplied it in front, and then subtracted that by 1. So here's the 3, and 3 minus 1 is 2. But our inside function remained the same. Now we're going to find the derivative of that middle function, the derivative of the inverse sine of 5x squared. So the derivative of the inverse sine is going to be 1 over the square root of 1 minus u squared. So in this case, our u is 5x squared. So we're going to have 1 over the square root of 1 minus u squared, which is 5x squared squared. And then lastly, we're going to multiply by the derivative of that innermost function, 5x squared. So 2 gets multiplied to 5, and then decrease that exponent value by 1. So 2 times 5 is 10, and x squared is x to the first. So now we need to simplify all of this. And how we're going to do that, I'm going to take 10x and multiply that by 3, and that quantity will be multiplied by the inverse sine of 5x squared, and that all is going in the numerator getting multiplied by 1. So writing my numerator, 3 times 10x times 1 is 30x. So I'll have 30x times the inverse sine of 5x squared, and that's all over my denominator of the square root of 1 minus, now I'll expand out 5x squared. 5 squared is 25 times x squared is x to the fourth. And that's my solution in number 5. 30x times the inverse sine of 5x squared divided by the quantity, the square root of 1 minus 25x to the fourth. Moving on to number 6, we're going to be using the chain rule again. But I want to point out, unlike number 5, we're not cubing the entire quantity. We're only cubing what is inside the inverse sine. So the inverse sine is our outermost function. So we're going to take the derivative of the inverse sine of u, and that will get multiplied by the derivative of 3x to the fifth plus 1 cubed, and then multiplied by the derivative of 3x to the fifth plus 1. So the derivative of y with respect to x is going to be the derivative of the inverse sine of this entire function. So let's say u. So if we set u equal to 3x to the fifth plus 1 cubed, and this will be u sub 1, when we take the inverse sine of u sub 1, that will be 1 over the square root of 1 minus that entire inside function u sub 1, 3x to the fifth plus 1 cubed, but that entire quantity squared, u sub 1 squared. Now we're going to take the derivative of that middle function. So when we take the derivative of our next function, that's going to be the derivative of what u sub 1 was. So I'm going to make u sub 2 equal to just 3x to the fifth plus 1. So when we take the derivative of u sub 2 cubed, that's going to be 3 times u sub 2 squared. So visually we can see that we're just going to take this 3, bring it down in front, and then decrease that exponent by 1. So that's going to be 3 times our u sub 2 value of 3x to the fifth plus 1, that innermost function, squared. And then finally we're taking the derivative of the innermost function, so finally taking the derivative of u sub 2, which is the derivative of 3x to the fifth plus 1. This 1 is a constant, so the derivative is 0. So the derivative of 3x to the fifth, we're going to take this 5, multiply it by 3, and then decrease that value by 1. So 3 times 5 is 15 times x to the 5 minus 1, which is x to the fourth. Now it's time to simplify everything. So in my numerator, I'll have 1 times 3 times the quantity 3x to the fifth plus 1 squared times 15x to the fourth. So what I'm going to do is I'm going to multiply my 15x to the fourth by 3, and then that will get multiplied by 1. So 3 times 15x to the fourth times 1, well, 3 times 15 is 45, so that'll be 45x to the fourth, and then that gets multiplied by the quantity 3x to the fifth plus 1 squared. And that's all over my denominator. So the square root of 1 minus, now I'll be able to simplify my denominator. And how we'll go about doing that, as you can see, that I have my function cubed squared. So that's going to be the function to the 3 times 2. So that's going to be 3x to the fifth plus 1 to the 3 times 2, which is 2 the 6th. And that's my final solution in number 6. 45x to the 4th times 3x to the 5th plus 1 squared all over the square root of 1 minus 3x to the 5th plus 1 to the 6th. So let's continue on to number 7. In number 7, we have y equal to the cosine inverse of 4x squared squared. So the function squared is my outermost function. So y is going to equal u, that function squared. And u, we can see, is the inverse cosine of 4x squared. But this 4x squared will be some function v. So I'll have the cosine inverse of v, and v is equal to 4x squared. This is just writing out each of the separate functions within my function y, so that when I do the chain rule, you'll see each of the derivatives. So the derivative of y with respect to u, that's going to be 2 times u to the first. The derivative of u with respect to v is going to be the derivative of the inverse cosine of v, which is negative 1 over the square root of 1 minus v squared. And then finally my derivative of v with respect to x equals the derivative of 4x squared, which 2 times 4 is 8, and x to the 2 minus 1 is x. So in order to get my derivative of y with respect to x, I need to multiply my derivative of y with respect to u times the derivative of u with respect to v times the derivative of v with respect to x. Derivative of y with respect to x. And as I write this out, I'll just plug in my u, my v, and x is what I'm differentiating with respect to. So the derivative of y with respect to u is 2u to the first, so that's going to be 2 times u, which u is the inverse cosine of v, so we're going to plug in v into that to get the cosine inverse of 4x squared. That is the derivative of y with respect to u. So that will get multiplied by the derivative of u with respect to v, which is negative 1 over the square root of 1 minus v squared. But v, we know, is 4x squared. So that's 1 minus 4x squared squared, and then that will get multiplied by the derivative of v with respect to x, which is 8x. So you can see that now for dy dx, all I have are x variables, which is what I want. So simplifying that, I'll multiply 8x to 1 and to 2 times the inverse cosine of 4x squared. But this isn't just 1, it's a negative 1. So 2 times negative 1 is negative 2, and negative 2 times 8 is a negative 16, so that's negative 16x, because that 8 was multiplied by x, and that is multiplied by the inverse cosine of 4x squared. So that's my numerator, and that's all over our denominator, which is the square root of 1 minus 4x squared squared, so 4 squared is 16, and x squared squared is x to the 4th. And that's my solution in number 7. Negative 16x times the inverse cosine of 4x squared all over the square root of the quantity 1 minus 16x to the 4th. Now onto our last problem, number 8. So in number 8, again, I want to note that this cubed is applied within that inverse cosine. So that is going to be our outermost function. So y is going to be equal to the inverse cosine of u. Therefore, u is going to be set as some function v cubed. And v is going to be our innermost function, negative 2x cubed minus 3. So if I was to plug v in, and then plug that, u in, you could see that that's my function. So now it's time to take the derivative of each. The derivative of y with respect to u is the derivative of the inverse cosine of u, which is negative 1 over the square root of 1 minus u squared. Now the derivative of u with respect to v is going to be 3v to the 3 minus 1, which is 3v squared. And then lastly, the derivative of v with respect to x equals the derivative of negative 2x cubed minus 3, which is 3 times negative 2, which is negative 6, times x to the 3 minus 1, which is x squared, and then we're subtracting the derivative of a constant, which is 0. So now, for dy dx, the derivative of y with respect to x, I'm going to multiply each of those together. However, I'm going to plug in my values of u and my values for v. So I'll have negative 1 all over the square root of 1 minus u squared, which u is v cubed and v is negative 2x to the third minus 3. So that's going to be, as opposed to u squared, it's going to be negative 2x cubed minus 3 cubed, and that quantity squared, because this is v cubed, which is u, so u squared. So if you need to, feel free to make a note that v cubed is negative 2x cubed minus 3 cubed. So for u, you're plugging in this entire quantity. So that will get multiplied by the derivative of u with respect to v, which is 3 times v squared, which v we know is negative 2x cubed minus 3 squared, and then that gets multiplied by the derivative of v with respect to x, which is negative 6x squared. So you can see that once we take the derivative of each of those and plug the appropriate functions back in, all we have are x variables in our derivative equation. So now what I'm going to do is I'm going to multiply out the numerator. So this is a negative 1, which will get multiplied by 3, which will get multiplied by negative 6x squared, and that will get multiplied by the quantity negative 2x cubed minus 3 squared. So again, I'm taking negative 1, multiplying it by 3, and multiplying it by negative 6x squared. So that's going to be negative 3 times negative 6, which is a positive 18, and that's multiplied by x squared, but then I need to multiply by that negative 2x cubed minus 3 squared. So that's my numerator, and that's all over my denominator of 1 minus, in order to simplify my denominator, I'm just going to multiply 3 by 2 because that quantity cubed is raised to a power of 2. So my exponents will get multiplied together by the law of exponents. So I'll have negative 2x cubed minus 3 to the 3 times 2, which is to the 6th. So my derivative of y with respect to x in number 8 is 18x squared times negative 2x cubed minus 3 squared all over the square root of 1 minus the quantity negative 2x cubed minus 3 to the 6th. And with that, we finish up our free KutaSoftware Infinite Calculus worksheet, differentiation using inverse trigonometric functions. If you have any questions, leave them in the comments below. And as always, like, subscribe, and share. Doing so lets me know that you're finding these videos useful, which encourages me to make more videos for you. Also, if you want to support me even further, feel free to become a patron. Go to the Patreon link in the description below to find out more information.